Okay, so I've got this bar AB. It's moving as shown there, and given the velocity of A. I want to figure out what the angular velocity and acceleration of AB is. So I'll start with the velocity, since I will likely need that for the acceleration equation. And I'm going to write it for AB. So I'm going to start with my velocity equation like this. The velocity of B equals the velocity of A plus omega AB crossed with r of b with respect to a. So let's start with what I know about the velocity of b. So the velocity of b is going to be tangent to this path, right? Meaning this is going to be a 60-degree angle right there, okay? Now, I don't know what its magnitude is, but it's definitely going to be going in that direction as a moves down. So it'll be following that path. So the velocity of b then equals negative velocity of b. This isn't to the left, and that'll be sine 60i, and then plus vb cosine 60 in the j direction. Okay, so that gives me the velocity of b, at least the direction of it. Now, moving on to the velocity of a, again, that's given to me. The velocity of a is simply -4 in the j direction. So we'll go ahead and jot that down like so. And then I have the omega cross r that I'm looking at, which will be omega AB crossed with r of b with respect to a. And again, I don't know omega AB, that's what I'm looking for. So I know it's in the k direction. So I don't know if it's positive or negative, so I'll just assume positive. If I'm wrong, then I'll get a negative answer. Okay, and that's going to be crossed with b with respect to a. So that's from a to b. So in the x direction, it moves 2 plus 2 cosine 60. In the I direction, and then in the j direction, it moves 2 plus 2 sine 60. That'll be in the j direction. Now, if I do that cross product, I get 3 omega AB in the j direction and negative 3.73 omega AB in the I direction. Okay. Now I can break it up into x and y components, right? So my I component for VB is negative 0.866 VB equals negative 3.73 omega AB, and then I get 0.5 VB equals negative 4 plus 3 omega AB, right? Now, two equations, two unknowns. I find that the velocity of B, which I may need later, I'm not sure, is 20.4. That would be feet per second. And omega AB, which is what the first thing that I'm looking for, is 4.3 or 4.73 radians per second. And again, I get a positive answer. That means it is counterclockwise, which is what I assumed it was going to be. Okay, so now I've got that. Now I need to move on to my acceleration equation. Okay, so I'm going to go ahead and write a similar acceleration equation. Let me start by just blocking this off so there's no confusion about which is which. So again, now I'm going to go the acceleration of the acceleration of B equals the acceleration of A plus alpha AB, which is what I'm looking for, crossed with R of B with respect to A minus omega AB, which I just found, squared times R of B with respect to A. like so. So we're going to go through the same process. Now, acceleration of b has a tangential and a normal component, right? So I've also got a normal component back towards the center of that, okay? That's based on the velocity, which I've already found. So let's go ahead and start by writing. I should know the acceleration of b, at least the normal component. So I've got a tangential component, a, b, t, and I'm going to cross that, or not cross it, I'm going to multiply it times r, which is going to be 2 times the so this is to the left, so it's negative 2 times excuse me, I don't need the 2 because I'm finding the acceleration, I'm not doing alpha, so it won't be that. I don't need to worry about the 2 because I don't need to find the alpha of that. If I wanted to find the alpha of it, I'd need that in there. Okay, so it's just going to be AB times negative sine 60 in the I. I just know the direction of this, plus cosine 60 in the J, just like I had with the velocity in the previous part of the problem that I was working on. Now I know the normal acceleration, again, is going to be down and to the left. So it is v squared over r, so that's going to be plus 20.4 squared over r, which is 2. And again, now this is going to be negative, that would be negative cosine 60 negative cosine 60 in the I, and then negative sine 60 in the J. Okay, so that's the acceleration of point B, both a tangential and a normal component to it. So I'm going to leave that as is. It's a little ugly and messy, but we're going to leave it like that. Now the acceleration of A, and again, I know the acceleration of A is downward at 7 feet per second squared, so the acceleration of A is just simply negative 7j. Okay, now I have alpha AB, which I don't know, which is what I'm looking for. What I do know is it's in the k direction, positive or negative, so I'll say alpha ABK. If I'm wrong, I'll get a negative answer. Okay, crossed with, again, that r vector, which I've already found earlier. It's the same r as I had before, so I get 3 in the I and plus 3.73 in the J. And again, that comes from the 2 plus 2 cosine and the 2 plus 2 sine, which was given right down here. Okay, so when I do that cross product, I get 3 alpha A B in the J direction and minus 3.73 alpha AB in the I direction. Okay, so this is again very similar to what I had with my velocity equation that I was just working on. Okay, and then I have my last term, which is negative omega AB squared times the r of b with respect to a. So again, I'm going to have negative, and now that omega AB again is the 4.73 squared times that r vector, which again is 3I plus 3.73 J, okay, which, figuring it out, is negative 67.2 I minus 83.6j. So now I can break it up into my x and y equations, right? So in the x component, I have, unfortunately, I didn't finish this out, so I'll write these equations and I'll assume you guys can solve them on your own. So in the I direction, I have negative ABT sine 60 minus 20.4 squared all over 2 cosine 60, and that equals negative 3.73 alpha A B and minus 67.2. In the y direction, I'll have ABT cosine 60 and negative 20.4 squared over 2 sine 60. That'll equal negative 7 plus 3 alpha A B minus 83.6. Okay, now I've got two equations, two unknowns, the acceleration of B in the tangential direction, as well as the alpha of AB, which is what I'm looking for. I'll let you solve those equations since I don't have them right here, but at this point you should be able to figure it out, the rest of the problem.